Hello everyone. In this video, we're going to be solving an equation for integer solutions. So we have x squared plus xy plus y squared equals x squared y squared. And we're going to be looking for integer solutions. Okay, let's go ahead and put everything on the same side. So we're going to get x squared plus xy plus y squared minus x squared y squared is equal to 0. So here my goal is to turn this into a quadratic equation. And so here's what I'm going to do. I have x squared and negative x squared y squared. So I'm going to factor out an x squared here. So write this as 1 minus y squared x squared and then plus y times x plus y squared is equal to 0. So this is my quadratic in x. Now notice that my main variable here is x, so everything else is treated as a constant. Okay, so I have a quadratic in x, and I'm going to be solving this quadratic using the quadratic formula. So let's go ahead and solve this equation using the quadratic formula. All right, so I can write this as x equals negative b, which is going to be negative y, plus minus the square root of b squared. In this case, it is y squared minus 4 times a times c. c is y squared. And then all of that is divided by 2a, which is 2 times the quantity 1 minus y squared. So remember, x and y are supposed to be integers. So we can kind of look at what's happening inside the radical. We do have y squared minus 4y squared multiplied by, so let's go ahead and simplify this part. I have negative 4y squared, and then negative 4y squared multiplied by negative y squared, that's going to give us 4y to the 4th power. So we can safely say that this is equivalent to 4y to the 4th minus 3y squared. So that is going to be under the radical, 4y to the 4th minus 3y squared. And then all of that is going to be divided by 2 minus 2y squared. Now here, since we want x and y to be integers, how is that possible that this is going to be an integer? And obviously, notice that we can actually pull out the y squared from here. So we can kind of write this as x equals negative y plus minus. You know, if you pull out a y, the absolute value will be taken care of the plus minus. And inside the radical, you're going to have 4y squared minus 3. Great. So now the y is out. And what I have under the radical is much, much simpler. So now I have 4y squared minus 3. And in order for this to be an integer, which means it's an element of the set of integers, which we denote by the special z, that means x is an integer and y is an integer. The expression inside the radical needs to be, you know, an integer. Okay, so how can I write that as an integer? So I can safely say that, okay, 4y squared minus 3 needs to equal something like n squared. Okay, and here n is an integer as well. That means it's an element of the set. Okay, now let's go ahead and put y squared and n squared on the same side. Therefore, we're getting difference of 2 squares from here. That's awesome. We got 2y plus n. We can factor this. And 2y minus n equals 3. Now notice that we got an expression that kind of looked complicated, but then we checked under the radical. The expression needs to be another integer, and now we did get an equation in the factored form, which is awesome. Now, since we want them to be integers, we're going to be checking different cases. For example, this can be a 3, this can be a 1, this can be a 1, this can be a 3, this can be a negative 3, this can be a negative 1, and this can be a negative 1, and this can be a negative 3. Since 3 is a prime number, those are the only cases we need to worry about. So let's go ahead and check each case. If the first case scenario is going to give us the following. From here, we get that, this is supposed to be n, not 1. 4y equals 4, and we get y equals 1 from here. And obviously we get an n value too. N is going to be, in this case, 1, I think, right? Okay, but that doesn't really matter because we're interested in finding x. And by the way, how do you find x if you know that y is equal to 1? You can kind of refer to the original expression, which is kind of easier to calculate probably. So we have x squared plus xy plus y squared equals x squared y squared. So if y is equal to 1, then you get x squared plus x plus 1 equals x squared. X squared cancels out, and from here you get x equals -1. Great. So that is the case for the first case scenario. Now let's go ahead and take a look at the second case scenario. If 2y plus n is equal to 1 and 2y minus n is equal to 3, they're just going to switch around. But guess what? From here, we get the same y value. And when you plug in the same y value, obviously, you're going to be getting the same x value. So it's not going to give us anything different. But what about the other cases? Like, is it possible to get -3? Let's take a look at this one first. Suppose this is a 3 and the second one is a 1. So from here, we're going to be getting 4y. I'm sorry. I'm supposed to be looking at the negatives, not the, okay. -3 and -1. So it's supposed to be -3 and -1. So from here, 4y is going to be -4 and y is going to be -1. Now, if y is equal to -1, let's go ahead and check out this equation. X squared minus x plus y squared, which is 1. And on the right-hand side, we're going to get x squared again. And in this case, x is going to be +1. So we kind of have a situation where x and y kind of switch around. And, you know, when you do the other case, which is, I don't have to worry about this anymore because it's clear. But what happens if I have the other case scenario? It's going to be exactly the same thing because the y value is not going to change. Therefore, the x value is going to be the same as well. Okay, so we got another solution here. So far we got -1, 1. We got 1, -1. Are those the only solutions? Well, there's one thing that we kind of overlooked. If you go back here and look at the original problem, we also noticed, or we should notice that x equals 0 also satisfies this equation. Now, why is that happening? If you look at your quadratic equation here, you'll notice that if y is equal to 0, obviously, x is going to become 0. The denominator is not going to be 0. So everything looks good. In other words, 0, 0 also satisfies this equation. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.